With Doubtnut, get instant video solutions to all your maths, physics, chemistry, and biology doubts. Just click the image of the question, crop the question, and get instant video solution. Download Doubtnut app today.
Hello everyone. So the given question is, consider a particle moving in simple harmonic motion according to the equation x equals to 2 cos 50 pi t plus tan inverse 0.75, okay, where x is in centimeter and t in seconds. Okay, this motion started at t equals to 0 and we have to find out three parts. The first part is, when does the particle come to rest for the first time? The B part is, when does the acceleration has its maximum magnitude for the first time? Okay, and the option C is, when does the particle comes to rest for the second time? Okay, now first thing, when does the particle comes to rest? Okay, so if the velocity of the particle is 0, then the particle comes to rest. This implies that the particle is at rest. Okay, so we are given with the equation of displacement of simple harmonic motion as 2 cos 50 pi t plus tan inverse 0.75. Okay, now as we know that velocity is given by rate of change of displacement dx over dt, so if I differentiate the expression of displacement, I will get minus 2 50 pi into sine 50 pi t plus tan inverse 0.75. Okay, now again I have to put v equals to 0 and find out the time. Okay, since I have to, in the first option, when does the particle come to rest for the first time? Okay, I have to find out the time at which velocity is 0 for the first time. Okay, so if I put v equals to 0, I will be getting minus 100, 0 equals to minus 100 pi into sine 50 pi t plus tan inverse 0.75. Solving this further, I will be getting sine 50 pi t plus tan inverse 0.75 equals to 0. Now, for this to be possible, for sine theta to be 0, okay, for sine theta to be 0, theta can be 0, can be pi, can be 2 pi, and so on. But if I put theta as 0, then t will come out to be negative. Okay, so I am selecting theta to be pi. Okay, since it is saying that time for which it is coming to rest for the first time. Okay, so 50 pi t plus tan inverse 0.75 should be equals to pi. Okay, now we have to find out the value of t. So t should be equals to pi minus tan inverse 0.75 divided by 50 pi. Okay, so this is the time when the particle comes to rest for the first time. Okay, now after substituting the all the values of pi and tan inverse 0.75, I will be getting time as 1.6 into 10 raised to power minus 2 second. So 1.6 into 10 raised to power minus 2 second. Now the second part says that we have to find out the time when acceleration has its maximum magnitude for the first time. Okay, maximum magnitude for the first time. Now we know that acceleration equals to rate of change of velocity with respect to time. Okay, so I have to differentiate the expression of velocity with respect to time for getting acceleration. Now the velocity expression was this, minus 100 pi into sine 50t plus tan inverse 0.75. So I will differentiate it. I will be getting minus 100 pi into 50 pi. So I will be getting minus 100 pi into 50 pi into the function was of sine. The function was of sine. So the differentiation of sine will be cos. So cos 50 pi t. So it will be cos 50 pi t plus tan inverse 0.75. Okay, now for this to be maximum, for acceleration to be maximum, this value is negative. Okay, so this has to be the least negative, and the least negative, the cos can be equals to minus 1. Okay, So for maximum value of acceleration, cos 50 pi t plus tan inverse 0.75 should be equals to -1. Now for this to be possible, theta has to be pi. Okay, so I'm writing 50 pi t plus tan inverse 0.75. Okay, let me draw the graph of cosine first to get a better idea. The graph of cosine is like this. This is at pi by 2. This is again at pi. It is at least value which is equals to, at a value of pi, it is at least value which is equals to -1. Hence this should be equals to pi. Okay, so if I solve this further, I will be getting t as t equals to pi minus tan inverse 0.75 wholly divided by 50 pi. Okay, after solving this on putting respective values, I will be getting time same as in previous case, which is equals to 1.6 into 10 raised to power minus 2 second. Now the third part is given as when does the particle comes to rest for the second time. Okay, so I have to put the velocity expression equals to 0 and select the value of theta so that it is after pi. Okay, now the velocity expression was given to be, this was the velocity expression, this was the velocity expression. Okay, in this case I have put theta to be pi. Okay, now for next time interval I will be putting theta to be 2 pi. So 50 pi t plus tan inverse 0.75 should be equals to 2 pi. Okay, so 50 pi t plus tan inverse 0.75 should be equals to 2 pi. In this case I will be getting time as 2 pi minus tan inverse 0.75 wholly divided by 50 pi. Okay, after solving this on putting respective values, I will be getting time on which particle comes to rest for the second time is 3.6 into 10 raised to power minus 2 second. Okay, so these are all the three parts. I hope you understand. Thank you.
For class 6 to 12, IIT JEE and NEET level. Trusted by more than 5 crore students. Download Doubtnut App today.